Hello, my name is Sam Flournoy, and on behalf of Flournoy Green Tech, I'd like to walk you through the steps to make 60 gallons of biodiesel with my biodiesel processor that I made from scratch. Before we start the batch, I would like to show you a few elements that make the process much more simple and much more safe. Our processor is equipped with these pneumatic valves. Pneumatic simply means air-powered. And the way they work is we have our air line coming in from here. It goes into the solenoid valve, and the solenoid valve either releases the air pressure or builds up the air pressure in the valve, and that makes the valve turn one way or the other. And we can see which way the valve is turned by the indicator here. We have 3 pneumatic valves, all switch operated. This is valve number 1. It is a 3-way valve, and it directs the flow from the processing tank either here, where we can drain glycerin or take a sample of the biodiesel or oil, or it goes over here, which puts the oil or biodiesel into this pump, which pushes it to a different location. This is valve number 2. It is also a 3-way valve, and it directs the flow from the pump upwards to the dry wash or downwards to the circulatory mix loop. This is valve number 3. Its main purpose is to drain the lines from here down into the bucket after the biodiesel has mixed. We have 2 timers, one for the main pump and one for the heating element. These timers simplify some steps in the process by turning off the pump or element after the appropriate amount of time has passed. This is our main diaphragm pump. Its main purpose is to mix the methanol and potassium hydroxide. We use a diaphragm pump to mix the methanol and potassium hydroxide because a circulatory pump has a motor that can produce a spark, and the spark can ignite the methanol fumes. So there is a slight danger in that, and diaphragm pumps are very powerful, so they can mix very well. This is our 1 horsepower circulatory pump. Its main purpose is to mix the biodiesel and push the biodiesel through the dry wash. This is our fill right flow meter. Its purpose is to count the gallons of waste vegetable oil that we were pumping into the processing tank. This is our 1/2 horsepower clear water pump. Its purpose is to pump the waste vegetable oil from its container into our processing tank. This is our Eco to Pure tower. It purifies the unwashed biodiesel. Once the biodiesel has come out of this, it can now run any diesel engine. This is our fume vacuum. It sucks off all of the harmful fumes as the biodiesel is being mixed. This is our long-term settling tank. Occasionally, we will get a bad barrel of oil that is filled with water and other contaminants. We simply take the oil, pump it into this tank, heat the oil up to about 140 degrees, let it settle for a week or 2, and drain off the bad contaminants and pump our good clean oil into our totes. These are called static mixers. The static mixer on the left is used to mix the biodiesel and methoxide, and the static mixer on the right is used to mix the methanol and potassium hydroxide. This is our stainless steel temperature probe. It sticks deep into the tank and measures the temperature of the oil correctly. This is our sight tube. It visually tells us how many gallons of oil are in the tank at one time. The first step in making the biodiesel is you pump 60 gallons into the processing tank here via this blue clear water pump. The first step is to make sure that my flow meter is set to 0 and this valve here is open. Next, I come into my control panel and I open it up, and I'm going to turn on my waste vegetable oil pump here, and you can hear it pumping right now. And I just leave it on until it pumps 60 gallons of waste vegetable oil from this tank into my processing tank. So here you can see it filling up through my sight tube. We're now going to perform a titration test. You'll need the following materials: 4 sample cups, 3 syringes, phenolphthalein, isopropyl alcohol that is 70% purity or above, and a titration reference solution, and a magnetic stir. The first step is to pour a little bit of the isopropyl alcohol into one of the cups. So we're going to do that now. Don't need too much, just 20 milliliters or so for one titration. And now we're going to take some of the titration reference solution and pour a little bit into the other cup. You pour these in separate cups. Not too much, just a little bit. And now we're going to take our magnetic stir. You don't need a magnetic stir, it just makes things a whole lot simpler. You can mix it by hand by just twirling it. You set the magnetic stir there, and next you take 1 milliliter of your sample oil that you have taken. Put all that in there. Okay, now we're going to take our alcohol syringe, labeled A, and pick up 10 milliliters of the isopropyl alcohol from this cup. Get the air bubble out. So now we're going to squirt the 10 milliliters of isopropyl alcohol in with the oil, like so. Now we're going to start mixing the oil and the alcohol. So you can see them start to mix, and since alcohol and oil don't mix, you just need to get the bubble of oil thoroughly mixed throughout the alcohol. Once the alcohol and oil is thoroughly mixed together, you're going to take 4 drops of your phenolphthalein or indicator. 1, 2, 3, 4 drops of that, and let that mix for just a second. Once everything is thoroughly mixed, we're now going to take up 10 milliliters of the titration solution and start to slowly drop it into the solution of oil, alcohol, and your indicator. So now we're going to start slowly dripping it in here, and you'll see a slight color change, but what we're looking for is a real strong pink color. There's a little bit of a change starting to occur. So that's what we're looking for. And this should hold its color for about 20 seconds. So now that we have our titration results as 2, we now figure out how many liters we are processing. Since I'm doing a 60-gallon batch, 1 gallon has about 3.7 liters in it. So we're going to do 60. We're going to do 60 times 3.7 to get about 222 liters is what we're processing. And since we're using potassium hydroxide, we're going to use 7 grams per liter of for the process to take place. And you add that with your titration results. So since our titration results were 2, the total amount is going to be 9. We're going to do 9 grams per liter of oil. So times 9. So we're going to use 1,998 grams of potassium hydroxide to process our oil. There are a few other steps you should take when doing a titration test. To get your final titration amount, you need to calculate in your purity of your catalyst. For mine is 92%, so the total amount of grams is going to be 2,262 grams. The next step in the process is to weigh out the amount of catalyst you need with a scale. Again, my name is Sam Flournoy, and on behalf of Flournoy Green Tech, thank you for watching part 1 of this video. If you're still interested, please click down there to watch part 2.